Namaste to everyone. I welcome you all in my YouTube video channel. Today I will tell you our lecture on Legendre's equation, lecture number 11, in which I will solve some more problems on Legendre's polynomials. Now we solve problem number 4. Prove that p n plus 1 prime x plus p n prime x equal to p naught x plus 3p1x plus 5p2x plus plus 2n plus 1 pnx. In short, this equal to sigma r equal to 0 to n under bracket 2r plus 1 multiply p r x. Now we solve this. Solution. Since from recurrence formula theory we have 2n plus 1 pnx equal to pn plus 1 prime x minus pn minus 1 prime x. Prime means derivative with respect to x. This is number 1. Putting n equal to 1, 2, 3 n in 1, we get, if we put 1, this will be 3 p1x equal to p1 plus 1 2 prime x minus p1 minus 1 0 prime x. Now putting n equal to 2, 2 multiply 2, 4 plus 1, 5 p2x equal to 2 plus 1, 3 p3 prime x minus 2 minus 1, 1 p prime 1 x. Putting n equal to 3, 3 to the 6 plus 1, 7 p3x equal to 3 plus 1, 4 p4 prime x minus 3 minus 1, 2 p2 prime x and dot n equal to n minus 2. If we put here n minus 2, we get 2n, 2 multiply 2, 4 minus 4 plus 1 minus 3 p n minus 2 x equal to, here n minus 2 means p n minus 1 prime x minus, here n minus 2 means p n minus 3 prime x. Now putting n minus 1, here will be 2n minus 1 p n minus 1 x. Here n minus 1 means p n prime x minus p n minus 2 prime x. Putting n to n plus 1 Pnx equal to Pn plus 1 prime x minus Pn minus 1 prime x. Let this is number 2. Adding equations of 2, we get 3p1 x plus 5p2 x plus 7p3 x plus plus 2n minus 3 pn minus 2x plus 2n minus 1 pn minus 1x plus 2n plus 1 pnx equal to, here we see that p2 prime x and p2 prime x cancel. Similarly, p3 prime x and p3 prime x will be cancelled. Here last term pn minus 1 prime x, pn minus 1 prime x. Similarly, pn minus 2 prime x and pn minus 2 prime x will be also cancelled, and this term will be also cancelled. So remains in right side pn plus 1 prime x plus pn prime x minus this term also will be cancelled, p1 prime x minus p naught prime x. This will be equal to pn plus 1 prime x plus pn prime x minus d by dx. p1x means x minus d by dx, p naught x is 1. This will be equal to pn plus 1 prime x plus pn prime x minus 1, and this is 0, equal to pn plus 1 prime x plus pn prime x minus 1 is p naught x. P naught x implies that if we take p naught x left side, so p naught x plus 3p1x plus 5p2x plus plus 2n plus 1 pnx equal to pn plus 1 prime x plus pn prime x. We may write this in short: sigma r equal to 0 to n 2r plus 1 prx equal to pn plus 1 prime x plus pn prime x, and proved. Now we solve problem number 5. Prove that integration limit minus 1 to plus 1 under bracket x square minus 1 pn plus 1x pn prime x dx equal to 2n into n plus 1 by 2n plus 1 multiply 2n plus 3. Now we solve this. Solution. Since from recurrence formula 5 we have under bracket 1 minus x square p n prime x equal to n multiply p n minus 1 x minus x p n x implies that x square minus 1 multiplying both sides by minus 1 p n prime x equal to n, this will be first and this will be second, x p n x minus p n minus 1 x multiplying by p n plus 1 x in both sides. We get x square minus 1 p n prime x p n plus 1 x equal to n x p n x minus p n minus 1 x multiply p n plus 1 x, integrating both sides. We get integration. We take limit minus 1 to plus 1. X square minus 1 p n prime x p n plus 1 x dx equal to n outside integration limit minus 1 to plus 1 x p n x minus p n minus 1 x multiply p n plus 1 x dx, and this will be equal to n integration minus 1 to plus 1 limit x p n x p n plus 1 x dx minus n integration minus 1 to plus 1 limit p n minus 1 x p n plus 1 x dx. Let this is number 1. Since we know that integration limit minus 1 to plus 1 p m x p n x dx equal to 0 for m not equal to n, implies that integration minus 1 to plus 1 limit p n minus 1 x p n plus 1 x dx equal to 0. This is number 2. Also, from recurrence formula 1, we have 2n plus 1 x p n x equal to n plus 1 p n plus 1 x plus n p n minus 1 x, implies that x p n x equal to n plus 1 Pn plus 1x plus n Pn minus 1x by 2n plus 1. Let this is number 3. Putting 2 and 3 in 1, we get integration limit minus 1 to plus 1 x square minus 1 Pn prime x Pn plus 1 x dx equal to in integration minus 1 to plus 1 limit x Pn x, here from 3 we write n plus 1 Pn plus 1 x plus n Pn minus 1 x by 2n plus 1 multiply Pn plus 1x dx, and from 2 this term vanishes, means minus 0, equal to n by 2n plus 1. Integration limit minus 1 to plus 1 n plus 1 Pn plus 1 x whole square dx plus integration limit minus 1 to plus 1 in Pn minus 1 x Pn plus 1 x dx, and bracket closed, and this will be equal to n by 2n plus 1 bracket, this is n plus 1 integration limit minus 1 to plus 1 Pn plus 1 x whole square dx plus n, and this integration will be 0. This will be equal to n by 2n plus 1 multiply n plus 1, and value of this is 2 by 2n plus 1 plus 1, since Pn x whole square dx integration equal to 2 by 2n plus 1. We know this formula, so putting in place of n here n plus 1, this equal to 2 n into n plus 1 by 2n plus 1 multiply 2n plus 3. Proved. Now we solve problem number 6. Prove that number 1 integration limit minus 1 to 1 Pnx dx equal to 0 for n not equal to 0, and number 2 integration limit minus 1 to 1 p naught x dx equal to 2. Now we solve this. Firstly we solve number 1. From Rodrigues formula we have pnx equal to 1 by 2 to the power 10 multiply factorial nth order derivative of x square minus 1 whole to the power n. Implies that pnx integration minus 1 to the 1 dx. We take this outside, 1 by 2 to the power n factorial n integration limit minus 1 to 1 dn x square minus 1 whole to the power n by dxn dx, and this will be equal to 1 by 2 to the power n multiply factorial n. Integration of this is dn minus 1 dxn minus 1 x square minus 1 whole to the power n, means one derivative is reduced, limit minus 1 to 1. Let this is number 1. Now dn minus 1 x square minus 1 whole to the power n by dxn minus 1 equal to dn minus 1 by dxn minus 1. We factorize this, x minus 1 whole to the power n multiply x plus 1 whole to the power n. Now using Leibniz theorem we get here this is first function and this is second function. We are differentiating n minus 1th times. So first function will be differentiated n minus 1th order and second function remains same, plus n minus 1 c1. First function will be differentiated up to n minus 2th order and second function will be differentiated once, and plus dot 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 dot. Lastly, first function multiply differentiation of second function up to n minus 1th order, and we get this means x plus 1 to the power n, and this will be equal to factorial n by factorial 1 x minus 1. Second term will be n minus 1, c1 means n minus 1, and this will be x minus 1 whole square, and this by factorial to this, and differentiation of this will be n into x plus 1 to the power n minus 1, and plus dot 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 dot, and last term will be x minus 1 whole to the power n, and value of this will be factorial n multiply x plus 1. This is number 3. If we put x equal to 1 or minus 1, right side of 3 will be 0. Because if we put x equal to 1, 1 minus 1, 0, this term vanishes. This term x 1 minus 1, 0, here also 1 minus 1, 0. So, for the value of x equal to 1, right side of 3, 0. And if we put value of x equal to minus 1 plus 1, 0, here also minus 1 plus 1, 0, here also minus 1 plus 1, 0. So, here right side will be 0. Either if we put x equal to 1 or x equal to minus 1. Implies that right side of 1 will be 0. Because value of this is 0 for x equal to 1 and value of this is 0 for x equal to minus 1. So 0 multiply this thing is 0. Therefore, from 1 integration limit minus 1 to plus 1 pnx dx equal to 0 for n not equal to 0. Here we have applied n not equal to 0. Proved. Now we prove number 2. Since p naught x equal to 1, therefore integration limit minus 1 to 1 p naught x dx equal to integration limit minus 1 to 1 dx. This is equal to integration is x limit minus 1 to 1 and this equal to 1 minus 1. This is 1 plus 1 equal to 2. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.